Huwag ka nang umiyak sa mundong pabago-bago.
Solving quadratic equations by extracting square root is very easy. You just need to remember one thing. You can just apply this method if the given equation is in the form x squared is equal to k. Again, x squared is equal to k. So with this equation, it is very clear that the equation doesn't have a linear term. Okay, let's start. Number 1, x squared is equal to 49. So if you're going to look at the given, it really follows the form x squared is equal to k. Now if the equation is already in the form x squared is equal to k, the next thing that we are going to do is to extract the roots. So we will have the square root of x squared and the square root of 49. So it will become the square root of x squared is equal to the square root of 49. After that, you are just going to apply the square root property. So we will have x is equal to, what's the square root of 49? So we will have 7. And then, do not forget, applying the square root property, we will have x equals plus minus 7. Let us have our second example. 2x squared is equal to 200. Now, first thing, we are going to check if it follows the form x squared equals k. At first glance, I think you will be tempted to conclude that it follows the form x squared equals k. So, I invite you to investigate or to analyze thoroughly if it really follows the form x squared equals k. When we have this form, x squared equals k, it means that on the left side, it should be a perfect square. Because if it's a perfect square, then we can extract the roots. Now, going back to our problem, 2x squared. 2x squared is not a perfect square. Why? We have this numerical coefficient 2, and 2 is not a perfect square. So, the problem is really a problem because 2 is not a perfect square. But you know, mathematics is really beautiful because it gives us the idea that for every problem there is a solution. Now again, going back to the problem, our problem with this problem is we have this 2 which is not a perfect square. So what are we going to do? So recalling what you have learned before, it might be during your grade 7 times, we have these properties of equality. And mainly, we have the division property of equality, the DPE, meaning if we are allowed to divide both sides of the equation by any real numbers as long as it is not 0. Since our problem is we have this 2 which is not a perfect square, we can divide both sides by 2. Divide both sides by 2. And then I transfer the equal sign to make it more beautiful. Now, we can cancel 2 because 2 divided by 2 is equal to 1. So, we have x squared. And what is 200 divided by 2? That is equal to 100. Yes, if we are going to look at this form, x squared equals 100, it is very clear that it follows the form x squared is equal to k. So now, if we are sure that we already have this form, the next step is to extract the roots. So the square root of x squared and the square root of 100. Again, square root of x squared is equal to x. And then the square root of 100 is equal to plus minus 10. Okay, that's it. Let's proceed to our third example. 3x squared minus 147 is equal to 0. Now, it's very clear it does not follow the forms x squared is equal to k. But we can do something to produce this form. Now, going back to the equation, 3x squared minus 147 equals 0, you will have a quick reaction that this negative 147 or this minus 147 should not be on this side. So, applying the transposition which you learned during your grade 7 again, we can have this one. 3x squared is equal to 147. So, how did it happen? Recall that when you are going to transpose, you have two rules to follow. Always do the same thing on both sides of the equation, like what we did earlier. We divide both sides by 2. The second rule is when you cross the equal sign, you do the opposite operation. So for example, we have 3x squared minus 147. So the operation is minus 147. So what's the opposite operation of minus? It's addition. So when we cross the equal sign, this negative 147 will become positive. I know you already know that one. Now 3x squared is equal to 147. This form is very familiar if you're going to recall the second example. So I think you already know that the next step is to divide both sides by 3. Divide both sides by 3. Again, I will transfer the equal sign to make it more beautiful. Now divide both sides by 3. We will have x squared is equal to 147 divided by 3 is equal to 49. So again, one thing that is very beautiful with mathematics, this mathematics teacher create problems that are so easy for the students. So they make sure that when we divide something, it will produce a perfect square. Anyway, we are just on the introduction of solving quadratic equation. Now, this time it's already in the form x squared equals k, so we can extract the roots. Extract the roots. Square root of x squared equals x. Square root of 49 is plus minus 7. Okay, that's it. Let us have our last example. The quantity of y minus 4 squared is equal to 25. So upon looking at the problem, you might tell me that, sir, it does not follow the form x squared equals k. My answer will be, you use your imagination. What if you are going to imagine that the whole of this, the y minus 4 is just x? Diba? So, it will become x squared is equal to 25. Now, if you are going to look at this form, it already follows the form x squared is equal to k. Now, that's your imagination. Going back to reality, we have y minus 4 squared is equal to 25. It follows the form x squared equals k, as I explained earlier. One of the guarantee that it's a perfect square is this exponent 2, that this whole quantity is being raised to the exponent 2. Now, since we are sure that this is a perfect square, now we can extract the root. So, we can have the square root of y minus, the quantity of y minus 4 squared is equal to the square root of 25. Now, earlier, when we have the square root of x squared, that is equal to x. And why is that? Because this exponent 2 and then taking the square root are reverse operation. Meaning, when you have the square root of a square, it will just cancel with each other, leaving x. Now, applying the same property, the square root of y minus 4 squared, if we cancel the square and the square root, you will have y minus 4. And what's the square root of 25? That is equal to plus minus 5. Simply means that y minus 4 could be equal to positive 5, or y minus 4 is equal to negative 5. But it doesn't end in this part. We need to have a single value of y. So you will have y is equal to 5 plus 4. So if you are going to ask y plus 4, just recall the rules on transposition. If we have negative 4 and then we want that to cross on the other side because we want to find the value of y, we have the opposite operation. So since this is minus 4, we will have plus 4. And 5 plus 4 is equal to 9. So we will have y is equal to 9. In the other case, we will have y is equal to negative 5 plus 4. The same reason, the transposition. Now what is negative 5 plus 4? That is equal to negative 1. So y negative 1, if you are going to look at the two integers, they have a different sign or unlike sign. So we are going to subtract 5 minus 4 is 1 and copy the sign of the number with a greater absolute value, which is negative because 5 is greater than 4. So you will have y equals negative 1.